Hi everybody, this is the last of the AP net force practice problems. This is actually number 6 where you have an elevator with a passenger in it. So here's my little passenger there. He's so happy to be in an elevator, he's got his arms out. And they weigh a total of 1,500 kilograms, not newtons, but kilograms. And then on the other side of the elevator, we have a what's called a counterweight, and that is 2,000 kilograms. And this is what we call an Atwood machine. So sometimes in the AP test, you'll hear about something called an Atwood device. And you have to find the acceleration and the tension on each cable. Well, since these things are connected, the tension is going to be the same on both sides. And once again, I always start off with all these problems with the sum of all the force problems. So I'll tell you what, let's just do that right here. I'm going to have the sum of all the forces, but instead of doing the whole thing at once, I'm going to just look at the left-hand side, and then I'm going to come over here and look at the right-hand side. So let's do the left-hand side force. So the sum of all the forces on the left-hand side is going to be equal to the force of tension pushing up. You can see the force of tension right here. And then the force of gravity that pulls down on this weight over here. So now I have to plug in all those numbers. Well, I don't know what the force of the left-hand side is, and I know it's not 0 because the thing's moving. If I put more weight, 2,000 on the right-hand side and only 1,500 on the left-hand side, it's actually going to move. So if I don't know a letter, I have to substitute in a formula for it. Well, what is the formula for F? It's mass times acceleration. I'm just going to put a little L here so we know that's on the left-hand side. Then I'm going to have the force of tension, bring that down. And then the force of gravity is mass times gravity. It's the same thing as weight. Well, let's go ahead and plug in some numbers here. On the left-hand side, the mass is 1,500. I don't know what the acceleration is. In fact, that's what it's asking me to find. The tension, I don't know what that is either. So I'm going to put Ft over here. The mass on the left-hand side is 1,500, and gravity is negative 9.8. So I'll put that in there. So let's go ahead and figure out what acceleration on the left-hand side is. So the acceleration on the left-hand side is going to be, I'm going to divide both sides by 1,500. So that means you got to divide each one of these terms over here by 1,500. So Ft divided by 1,500 plus, well, 1,500 divided by 1,500 is 1. So that just gives you a negative 9.8 on this side. Well, whenever you have two unknowns in a formula, so for instance, I have AL and FT, which are both unknowns, I now have to use another equation in order to solve for one of those. So let's now solve for the acceleration on the right-hand side. I'm going to use another equation. Well, since I already used the equation on the left-hand side, let's now use the equation on the right-hand side. So I'm going to put this in green. Everything on the, so I'm going to have the force of all, the sum of all the forces on the right-hand side, but that also equals the force of tension plus the force of gravity on the right-hand side. Same exact formula again. That's the sum of all the forces on the right-hand side equals the force of tension plus mg. Let's plug in all of our numbers. On this side, though, I have 2,000. Now, I want you to watch what I do here with the acceleration on the right-hand side. Since this side over here is heavier, isn't this side going to go down, and this side over here on the 1,500 side is going to go up? So I'm going to have a negative acceleration over here on the right-hand side, where on the left-hand side it was positive because it was going up. And then I'm going to put in my Ft plus, it's getting 2,000 for my mass. Gravity is negative 9.8. And so let's solve for what acceleration is over here on the right-hand side. If you divide both sides by 2,000. In fact, let's go ahead and divide it by negative 2,000. That way we're actually solving for AR. Ft is divided by negative 2,000. Over here is going to be divided by negative 2,000. And so all this cancels out so that the acceleration on the right-hand side now equals the force of tension divided by negative 2,000 plus, now this 2,000 times the negative, and that negative 2,000 cancels out, so I'm going to add a plus 9.8 there. Well, now I have two different equations. One is for the acceleration on the left-hand side, and one is for the acceleration on the right-hand side. Well, since they're both connected, I know that both of these must be equal to each other. So what I'm going to do now is this. Since they must be equal, I'm going to plug the acceleration on the right-hand side in for the acceleration on the left-hand side, because they have to be equal to each other, and solve for the force of tension, because that's what they asked me to find, is what's the tension on the ropes. So watch what I do here. I'm going to bring this whole green formula over to this one. So I'm going to have Ft divided by 2,000. That's a negative 2,000. Plus 9.8 has to equal, now I'm going to bring down this stuff on the left-hand side over here, Ft divided by 1,500 minus 9.8. Let's get all the FTs on one side and all the 9.8s on the other. So I'm going to add 9.8 to both sides, and that's going to give me 19.6. And as well as adding 9.8 to both sides, I'm now going to add this FT over negative 2,000. I'm going to add that to both sides. So that cancels out on this side. And so you end up getting Ft. So that's going to give me this Ft over 1,500 plus Ft over 2,000. Now what I have to do is I got to figure out what Ft is. Well, you have to find a common denominator. So let's get this common denominator down here. And that's what makes this thing so difficult. Well, the common denominator is going to be 6,000. So that's going to mean that 19.6 equals 4 Ft over 6,000 plus 3 Ft over 6,000. This is getting to be a long problem here. So when you add those two things together, I'm trying to get this to go up, there we go. I now have 19.6 equals 7 Ft over 6,000. Let's do a little cross multiply here. And that means that 7 Ft equals 19.6 times 6,000. So now what we have is that 7 Ft equals 117,600. Let's divide both sides by 7. And you end up with a force of tension. So that means that Ft ends up equaling 16,800 newtons. And don't forget that Ft stands for the tension. Well, both ropes have the same tension on them. Well, now what you have to do, now that you know this, I'm simply going to plug that back in way up here. So if I shrink that down a little bit, you'll be able to see what I'm doing here. And so let's plug that answer in up here. So the acceleration on the left-hand side is going to be equal to Ft divided by 1,500 plus a negative 9.8. So all I do is put that number right in there of 16,800. Divide that slap at me by 1,500. Subtract the negative 9.8, and you get the acceleration on the left-hand side equal to 1.4 meters per second squared. So that's how you get that. Now, I have a much easier way to do it. You can do it this great big long way. That's the way your book tells you to do it. But I have a much easier shortcut for doing both sides. So get you another piece of paper and we'll do the shortcut way. Okay, so I erased all that and I want to show you my shortcut way. And I think that this works all the time, but just go with me and see if you like this way better. Once again, I never know what formula to start with, so I always start with the sum of all the forces. And I'm just going to look at one side, just like I did before. But I know that the force on the left plus the force on the right has to equal the sum of all those forces. Okay? So here's what we're going to do. Okay, so on this part right here, okay, so let's, we can't assume that the force of the sum of all the forces add up to 0, because with the right-hand side being heavier, we know this is going to move. So I got to substitute in a formula for the sum of all the forces, and the sum of all the forces equals mass times acceleration. But this is the sum of all the mass. Sorry about that, I keep getting interrupted. So the force on the left-hand side is going to be due to the weight of the left-hand side, so therefore it's going to be mass times gravity. And since this side is going down, we're going to make this side negative. And I'm sorry, this side's going up, so I got to make this negative, and I'll explain why in just a second. And then the force on the right-hand side is also the mass times the gravity of the right-hand side. So let's put in some numbers here, and once again, I'll explain why this is negative in just a second. Well, the sum of all the masses means that you got to add both of them together. So I'm going to take the 1,500 on the left-hand side plus the 2,000 on the right-hand side, and we're going to figure out what the acceleration is of those two things. And that equals the mass on the left-hand side. So that's going to be 1,500 times a negative 9.8. Well, the reason why that negative 9.8 is there because gravity pulls down. But you got to remember the acceleration of the thing on the left-hand side is going up. So I got to multiply that negative by a negative to make sure it's going up. Once again, the left-hand side goes up because the right-hand side is heavier. So I got to change that negative 9.8 to a positive. Then I'm going to do the right-hand side. Well, the mass on the right-hand side is 2,000 times negative 9.8 for gravity that's pulling down. And so when you do both sides here, you end up getting 3,500A equals this great big number over here, all put together, which is 14,700 plus a negative 19,600. And so now I'm going to divide both sides by 3,500. The whole thing gets divided by 3,500. And so the acceleration ends up equaling negative 1.4 meters per second squared. So I think that this is much easier than the other way of doing it. Now, if I want to figure out the tension on the string, just look at one side, and we're going to put in our answer here. So if we just look at one side, let's look at the formula. We're going to do the sum of all the forces, and just let's look at the left-hand side here. Okay, or outside the right-hand side. Do the right-hand side, and you can pick either one. It makes no difference. On the right-hand side, you got the force of tension on the rope acting up. You see that little triangle right there. And you also have the force of gravity pulling down. And so what I'm going to do here is I don't know what the total force is, so I'm going to substitute that in for mass times acceleration. The force of tension is what I'm trying to find. And the force of gravity, once again, is mass times gravity. So let's just plug in some numbers here. Well, on the right-hand side, the mass is 2,000. The acceleration, we got right there. Well, the acceleration is going down, so I'm going to put in a negative 1.4 meters per second squared. The force of tension is what I'm looking for. I'm going to add to that the mass, once again, of 2,000. Gravity is negative 9.8. And so let's go ahead and fill in all the numbers now. 2,000 times a negative 0.14, and you subtract 2,000 times negative 9.8. That ends up giving you a force of tension of 16,800 newtons. Now, if you notice, those two answers are exactly the same as we got when we did that great big long problem. So I like this way easier. It's much, much easier. I think it always works if you just sort of assume that two things. So anyway, you can do it either way. Hope you enjoyed the show, and we'll see you in class to do the rest of those problems. Love you.